My project is called SwatchBox. So I'm a painter, and sometimes when I'm out and about, I see a color and wish I could bring it home with me. And that's what SwatchBox lets you do. You can scan colors from life and mix those colors using paint. So the requirements for this project were to be able to add and delete paint and swatch colors, and then also scan swatch colors from life. Needs to be able to view the different color libraries and individual color details. Generate paint color formulas using an external API, so it needs to connect to the internet, and also save and load data from an SD card. So I used a multi-threaded event-driven architecture for this project. I have a main controller thread that manages the global state transitions, and then I have a UI manager thread, which controls the graphics rendering and touch event handling. And I also have worker threads that are used by the sensor driver and the API client to remain responsive and not block the UI. I have a Wi-Fi controller that the main controller calls it boot to try and connect to some hard-coded network details. And then also a storage manager that's called it boot, where we load the SD card data. I just wanted to look at the UI implementation real quick. So I'm using the LVGL library, and I've defined several screens that are switched between based on incoming events from the main controller, and those are processed by the UI manager. I kind of think of it as a secondary controller just because of the nature of the project. The UI needs to know about several of the components, so a lot of the business logic flows through it. And I think the UI was kind of the most time-consuming part of the project, just because it took forever to get all these little screens built. They're pretty complex, and there's a growing pains with LVGL. So I used Zephyr Z-test to test the system controller, just the different transitions and entry and exit functions. And then I also tested the storage manager, so the saving, loading, deleting of colors from the SD card and memory. So I hit a couple limitations. The main one was RAM. I used up pretty much everything my board had to offer. Also some rate limiting from the color mixing API. So in my demo, that bit is mocked, but it's a real API response, so it looks the same. And then the screen orientation, I really wanted my project to be in profile, but I couldn't figure out how to rotate the screen, so oh well. Let's look at the demo. Okay, so this is my STM32 discovery board with my touchscreen shield on top, and I have a micro SD card connected, and then I'm using an Adafruit APDS 9960 sensor connected using a STEMMA QT port. So on boot, you are taken to the target color library page with colors populated from the SD card. And you can see more details about the color by clicking on it. And you can also look at the paint colors. Oops, let's look at green. Okay, you see the details there. And then we can add a color, and you can switch between the kind of color you'd like to add. And both pages have an input field for entering the hex of the color you like to add. And we have a swatch here that updates dynamically with the input field. So let's say I want to add FCF. It's a small keyboard. Here we go. Okay, we want to add this yellow color. So you can also name the colors. So let's call it 78. Yellow 78, okay. And then save. So we have our new paint color. And if we scroll to the bottom, we can see our new paint colors there. And resetting, we can go back to the paint colors. It's still there because it was saved to the SD card. Oops. Okay, and then if I can click on it. Screen's a little finicky. Okay, click on it, let's delete it. And it's gone, there's nothing there. And then after resetting, just to be completely sure. Yeah, it's gone. There's nothing there. Okay, so when adding a target color, you can also scan the color. So let's just scan this orange yarn here. And you just do this by pointing the sensor at what you want to scan. And I find it needs a lot of light for a good reading. So this is just a flashlight. There we go. That's pretty good. So then you can save that color if you'd like. So the last thing is mixing colors. So let's say we want to mix this purple color using the paint colors that we have. So you just hit mix color. And so we see we cannot get like 100% the same exact world purple color, but we can get this hex code, which is very close to our original one. And these are the 3 paint colors we can mix together and their ratios to make that color. So that's it.